Okay, welcome. In this lecture, we will discuss the electric flux through a cube, right? This is a very interesting thing here. So we have four cases of the electric flux through a cube. First, I will take here the charges at the center of the cube. So when the charge is at the center of the cube, then by Gauss's theorem, we can simply say the total flux is equal to charge enclosure divided by epsilon naught. Since the charge is symmetrically placed with respect to the six faces, right? So the flux through six faces is equal to Q divided by epsilon naught. So this implies the flux through each face is equal to Q divided by epsilon naught. But here we are using the Gauss's theorem, so we have to first calculate the flux through the whole cube, then we can calculate the flux through each cube. Now the question is there any direct method by which we can calculate what is the flux through each face of the cube? So that I will discuss later on. Now second thing is, when the charge is at the corner of a cube, so if we look at this system, so we have to enclose this charge, so we need 8 cubes so that this charge is completely enclosed. That means contribution of the charge in each cube is equal to Q divided by 8. Or we can say the charge enclosed in this cube is Q divided by 8. So the total flux is charge enclosed divided by epsilon naught, that is Q by 8 epsilon naught. But here only 3 faces are of the interest because this charge lies in this face, and in this vertical face. So the flux through these faces, the electric field lines through these faces will be parallel to the plane of the faces, so there will be no flux through them. So only 3 faces are left now, that is 3 times flux through face is Q divided by 8 epsilon naught, so that is phi F is equal to Q divided by 24 epsilon naught, right? So this is the case when the charge is placed at the corner, right? Now there is another case, that is when the charge is at the face center of the cube. When the charge is at the face center of the cube, then we need another cube to completely close this charge, to enclose this charge. So charge enclosed in each cube is Q divided by 2. So that means the total flux through these 5 faces except this face, because through this phase the field lines will be parallel to the plane, that is equal to Q divided by 2 epsilon naught. Now is the flux through all the faces same? Are the 5 faces symmetric with respect to this charge? So if they are symmetric, then we can write 5 times flux through each face is Q divided by 2 epsilon naught. That means flux through each face is equal to Q divided by 10 epsilon naught. But since the faces are not symmetric with respect to the charge, the flux through this face, and this front face and this back face are symmetric. So flux through all these faces is same, but flux through this face is not same as that of other 4 faces, right? So that means the flux through this ABCD is not equal to flux through the other 4 faces. Now, is there any way to calculate the flux through this face and the other faces directly, so that we can add them and we get the total flux through the cube is Q divided by 2 epsilon naught. Now the fourth case of interest is when the charge is at the edge center. So I place the charge here at the edge center. This is the charge here. I place it at the edge center. Now for the edge center, I need a cube here on this side, on the front side, and then here 2 cubes again. That means total 4 cubes to enclose this charge completely. So that means the charge is shared by 4 cubes. So charge enclosed by each cube is Q divided by 4. So total flux through this cube will be then equal charge enclosed by epsilon naught. That is Q divided by 4 pi epsilon naught, right? Now the question arises here, what is the flux through each face? First of all, the flux through this face and the flux through this face that contain the charge, right? The two faces that are that contain this charge will have zero flux, because the field lines will be parallel to the plane of these two faces. Now remains here four faces. One is this face, that is ABCD, and second is this CBFG, right? These are symmetric with respect to the charge. And then there is another two face. One is this bottom face and the top face. So they are also symmetric with respect to the charge. The flux through this top and bottom face will be same. The flux through this face and this face will be same. But the flux through this face and this face is not same, right? So that is what I have included here. Now the question arises, how can we calculate the flux through these faces separately or independently? Is there any method to calculate the flux? Usually we see most of the teachers, they skip this, the books skip these things. But there is a method. We can calculate the flux through all these faces independently using the concept of solid angle. So if we know the solid angle subtended by each face at a point where the charge is located, we can calculate what is the total flux, right? So that the total flux through each face, and then we can calculate what is the total flux through the cube, right? Now, in this method, what we do, we calculate the total flux, and wherever it is possible to calculate the flux through each face using the symmetry, we do that. But in case of these problems, so we skip the flux through this face, we skip the flux through this face. So now we have the method. We can calculate the flux through each face if we know the solid angle subtended by each face at the chart. So for that, you have to follow the videos that are upcoming. So in those videos, I will calculate the flux through each face of the cube when the charge is located at different locations, that is at the center, at the corner, at the face center, and at the edge center.